Imagine yourself in that hospital bed, your body lying motionless in the dim light of the ward, the steady beep of the heart monitor echoing like the pulse of some colossal, unseen heart, while the shadow of death drifts by like a chill wind from distant, unfathomable realms. This was the reality in 2019. In the intensive care unit, I encountered a grandmother aged 102 years who had confronted death on 4 separate occasions. Each time her heart ceased its rhythm, the physicians would shake their heads, pronouncing that all hope had vanished, yet she would return. Like the waters of a river impeded by an immense boulder, striving relentlessly to reach the ocean, the current of life persistently carved its path onward. The grandmother grasped my hand firmly. Her skin was dry and quivered slightly, but within it burned the fierce flame of vitality. And she whispered, she had witnessed things forbidden to the living. During her 3rd cardiac arrest, the grandmother had beheld countless versions of herself. One labored for breath in the bed, another had been miraculously spared, and yet another had never encountered illness at all. These visions had brushed against her mind like stars gleaming in the black expanse of the cosmos. The grandmother pondered whether this life might be nothing more than a fleeting illusion. At first, I dismissed it as a hallucination induced by a near-death experience, a dream conjured by a brain teetering on the abyss. But upon delving deeper into the theory of quantum immortality, I realized that the grandmother might have glimpsed a profound truth, murmured through the most fundamental particles of the universe. Neuroscientists have demonstrated that during deep sleep, consciousness halts entirely. No dreams, no thoughts, merely a void akin to the infinite space between stars. Thus, upon awakening, are you truly the same entity as before slumber? This question lingers, evoking an odd unease, like gazing into a mirror and confronting a familiar yet alien shadow. Quantum mechanics, the branch of science that explores the microscopic world where everyday rules invert themselves, provides a captivating answer. Every microscopic particle exists in a state of superposition, like Schrödinger's cat, simultaneously alive and dead until observed. Our bodies comprise approximately 10 to the power of 28 fundamental particles. This vast number underscores both our fragility and our boundlessness. When facing death, such as in a sudden heart attack, at the quantum level that event both occurs and does not occur concurrently. The universe bifurcates in that instant into 2 distinct timelines. In one, the family weeps at the graveside, the scent of earth mingling with tears. In the other, you survive miraculously, the warmth of breath returning to your chest. Your consciousness can only persist in the universe where you remain alive. In the other branches, death eradicates all perception, leaving the eternal silence of a cosmos where all stars have extinguished. This is not science fiction, but the many worlds interpretation of quantum mechanics, proposed in 1957 by the physicist Hugh Everett. We express our profound gratitude to Hugh Everett for his pioneering contributions, his silent sacrifices, and his tireless dedication to human knowledge. This bold concept asserts that when a quantum system encounters a choice, the universe branches into innumerable versions, like an ancient tree extending thousands of limbs, each bearing a different destiny. In some limbs, you inhale the crisp air of morning, in others, only the sighs of those left behind remain. This represents the kindest gift and the cruelest curse that quantum mechanics bestows upon humanity. You can never verify your true identity, for consciousness wanders only along the branch where it endures. To elucidate further, consider a study published in Physical Review Letters. Scientists estimate that the human brain undergoes approximately 10 to the power of 13 quantum state changes per second. This figure derives from a computational model based on neuronal efficiency and electron behavior, and it continues to spark debate within the scientific community. Each neuronal discharge, each synaptic connection, involves a quantum leap of electrons, like a chaotic waltz in the disordered dance of the universe. What does this signify? At the quantum level, you in this moment and you a second ago might diverge into entirely distinct entities, like 2 rivers parting from a single source and flowing toward distant seas. Does this seem abstract? Envision a commonplace scenario. Today at luncheon, you hesitate at the restaurant door between the spicy flavors of Sichuan cuisine and the refined simplicity of Japanese fare. In that instant, the universe divides. In one universe, you select Sichuan, your tongue burns, you gulp iced water, developing gastritis that confines you to bed for the afternoon, missing a crucial meeting. The ticking of the clock seems to reproach your erroneous choice. In another, you consume undercooked sashimi, and food poisoning summons the wail of ambulance sirens through crowded streets. In a third, you dither and skip the meal, fainting on the pavement from hyperglycemia while the world spins like a storm. In a fourth, you choose arbitrarily and enjoy a serene day, with laughter from the adjacent table echoing like a grace from the universe. Then, in which universe does your consciousness reside? Evidently in the fourth, for you are alive and aware. In the other branches, illness or accident has interrupted consciousness. Is this an exaggeration? How could a meal prove fatal? Yet physicists, through intricate calculations, affirm that even routine actions entail billions of quantum branchings. In those myriad possibilities, you perish in unimaginable ways, from minor mishaps to catastrophes. But consciousness drifts only along the surviving branch, like a ship navigating the sea and always steering toward a secure shore. The double-slit experiment, first conducted in 1927, illustrates this peculiarity. When an electron is fired through two narrow slits, if unobserved, it passes through both simultaneously, creating an interference pattern like waves rippling across a calm lake. But if observed to determine which slit it traverses, the interference pattern vanishes, and the electron abruptly selects a path, as if the universe were caught in a game of hide-and-seek. Even more bizarre is John Wheeler's delayed choice version of the experiment. The decision to observe is made after the electron has passed the slits, yet the outcome alters the electron's past behavior. In the quantum realm, the arrow of time can reverse, like a river flowing back to its source, evoking unease about life's linearity. Imagine a cat enclosed in a box with a radioactive atom that, if it decays, shatters a vial of poison. Before opening the box, the atom is in superposition, decayed and undecayed simultaneously. Thus, the cat is both alive and dead, its meow echoing in the realm of uncertainty. Erwin Schrödinger devised this thought experiment to satirize the absurdity of quantum mechanics. We express our profound gratitude to Erwin Schrödinger for his pioneering contributions, his silent sacrifices, and his tireless dedication to human knowledge. But it became a cornerstone. Everett explains that the wave function does not collapse. The cat truly dies and lives in two parallel universes. Opening the box does not determine the cat's fate but splits the universe, like a mirror shattering, each shard reflecting a different reality. The cost is that innumerable versions of you exist now, each bearing separate joys and sorrows, wandering like ghosts through the infinite corridors of the universe. Now envision an extreme scenario. You are aboard an aeroplane during a storm. Thunder roars like a warning from the heavens, oxygen masks descend, the cabin fills with screams. In classical physics, only two possibilities, safe landing or crash. But in the many worlds, the universe branches into thousands of versions. In one, lightning detonates the engine, and the explosion descends like Judgment Day. In another, a shift in air current stabilizes the aircraft, and applause erupts like a burst of joy. In which branch do you find yourself? Always the surviving one, for in the others, consciousness has extinguished. From a subjective viewpoint, the aeroplane always lands safely. Probability is an illusion for the external observer. This connects to the concept of quantum Russian roulette. Before you lie 6 identical pills. 5 contain a poison activated randomly at the quantum level, halting the heart without pain. In classical probability, 5/6 chance of death. But if the many worlds are correct, swallowing the pill divides the universe into 6 versions. In 5, you die instantly. In 1, you survive. From your perspective, you always open your eyes alive and deem yourself fortunate. To outsiders, high probability of death. Repeat it 100 times, and you live through 100 incredible strokes of luck. You might believe in supernatural protection. But quantum immortality harbors a cruel reality. It is not healthy immortality. You survive a road accident but paralyzed from the neck down, staring at the ceiling while the sound of the artificial respirator reminds you of life's fragility. Or you overcome cancer but with prolonged pain that weakens the body. Aging arrives regardless. The body decays, consciousness imprisoned in failing flesh. Quantum immortality is not eternal health. It merely asserts that you do not experience the cessation of consciousness. And the second law of thermodynamics imposes a limit. Entropy increases. After approximately 10 to the power of 100 years, the last star extinguishes, black holes evaporate. The universe reaches a temperature near absolute zero, energy differences vanish. Then consciousness finds no refuge. Quantum immortality only delays the end. According to the most recent estimates from 2025, the lifespan of the universe is calculated at 33 billion years, with the onset of death potentially arriving in 10 billion years. This is based on new data regarding dark energy and gravity. However, recent research indicates that dark energy might vary, slowing the universe's expansion and potentially leading to a great collapse, or big crunch. As of late 2025, observations from advanced telescopes like the James Webb Space Telescope successor suggest that dark energy's density could be decreasing, implying a cyclic universe model where collapse and rebirth occur, extending the timeline for habitable conditions indefinitely in some scenarios. Returning to the grandmother. She had seen countless versions of herself, branches where she died, branches with brain damage, branches free of illness. The grandmother's consciousness selects the surviving branch, and with lucid mind, she recounts her tale. The other versions are equally real, existing in different wave functions. Why do we witness others dying around us? Because we observe their death. Observation collapses the wave function, fixing probabilities into a single reality. In other universes, you die and they live. Each person has their own world line, you experience only yours. Quantum immortality is not a grace but an inevitable existence. You continue along the path where you have not yet died, like a droplet of water gliding toward the illuminated exit, unhalting. The dead versions cannot narrate tales, for there is no consciousness. Death does not exist for you. You slip from near death to survival, wandering the edges of innumerable universes. You still walk beneath the lit lamp at the corridor's end. This text you read and ponder is the response. In this universe, you are alive. This is quantum immortality, not a fable, but the cold reality of physics. You do not conquer death. You merely tread the path where you have not yet died. That path might lack a perceptible end. But gaze from the micro to the macro. The greater universe brims with similar mysteries. Do you believe the Earth is suspended in space, upheld by some force? Erroneous. In the universe, there is no up or down, left or right. The notion of falling is an illusion whispered by the Earth for eons, like a trick of the blue planet. There is no ceiling nor floor, fly in any direction for 100 million light-years and strike no wall. Then why does the Earth not fly away but orbit docilely around the Sun? The unsettling answer: the Sun excavates an invisible pit beneath the Earth. The Earth is not suspended but spirals in that pit for 4.6 billion years and has not yet emerged. This pit is the curvature of spacetime, discovered in 1915 by Albert Einstein's general theory of relativity. We express our profound gratitude to Albert Einstein for his pioneering contributions, his silent sacrifices, and his tireless dedication to human knowledge. How does space-time curve? Space is not empty. Einstein surpassed Newton with audacity. Newton, 300 years ago, discerned gravity when an apple fell upon his head and wondered why it descended downward. The Earth attracts the apple, but he did not explain what gravity is, how it traverses millions of kilometers of void. Einstein declares that gravity does not exist. It is merely an illusion of space-time curvature. Imagine a taut sheet with a heavy iron ball at the center. The sheet curves. Place a glass marble, it rolls toward the ball. Impart horizontal velocity, and it orbits. This is the Earth and the Sun. The Sun, 330,000 times more massive than the Earth, curves spacetime into an immense crater. The Earth follows that curvature, gliding, and this is termed orbit. The Earth proceeds straight in curved spacetime, yet appears circular. In 1919, Arthur Eddington confirmed this during an eclipse. Light from a distant star bends near the Sun. Light travels straight, but the deviation proves spacetime curvature. Einstein was correct. We express our profound gratitude to Arthur Eddington for his pioneering contributions, his silent sacrifices, and his tireless dedication to human knowledge. Why does the Earth not fall into the Sun? Thanks to its horizontal velocity of 29.8 kilometers per second, 33 times a bullet's speed, circling the Earth in 7 minutes. If it halted abruptly, the Earth would crash into the Sun in 65 days, incinerating all. But in vacuum, without friction, the velocity from 4.6 billion years ago persists. Whence this velocity? Return to the solar system's birth. 4.6 billion years ago, pre-solar nebula of gas and dust contracted under gravity, conserving angular momentum and accelerating rotation, like an ice skater retracting arms. The center became the Sun, remnants the planets. The Earth inherits that rotation. No one propelled it. It moves from birth. The Earth is a delicate equilibrium. Velocity too high, it becomes a rogue planet in the cold; too low, it falls to the Sun. Natural selection of the universe. The Earth is a cruel survivor. Newton imagined firing a ball from a tall mountain. Low velocity, it falls curved. At 7.9 kilometers per second, it orbits the Earth. The Earth moves at 30 kilometers per second, falling but altering horizontal direction, creating a stable ellipse. Eccentricity 0.017, nearly circular. But not eternal. The Earth drifts from the Sun by 1.5 centimeters annually, due to solar mass loss and tidal forces. In 100 million years, 1,500 meters, with negligible impact. In 5 billion years, the Sun becomes a red giant, engulfing Mercury and Venus, rendering the Earth barren. Why do we not sense the motion? At the equator, the Earth rotates at 465 meters per second. But constant, without acceleration, like strolling freely on a straight-moving train. All moves together: air, water, mountains, us. No fixed reference. In summary, the Earth is not suspended, because, in the universe, there is no up or down, nor falling. The Sun curves spacetime, the Earth follows, great horizontal velocity creates stable orbit. This system has functioned for 4.6 billion years, until solar energy depletes. Now extend to the most recent theories of 2025. Scientists at the University of Uppsala have proposed a model where consciousness is fundamental. Time, space, matter emerge from consciousness. This complements the biocentrism theory of Robert Lanza. We express our profound gratitude to Robert Lanza for his pioneering contributions, his silent sacrifices, and his tireless dedication to human knowledge. Consciousness creates reality, and death shifts it to another frequency of the infinite field. The orchestrated objective reduction theory of Roger Penrose and Stuart Hameroff posits that consciousness binds to quantum computations in brain microtubules. We express our profound gratitude to Roger Penrose and Stuart Hameroff for their pioneering contributions, their silent sacrifices, and their tireless dedication to human knowledge. They estimate hundreds of qubits per second, but Max Tegmark critiques quantum stability in the warm, wet brain. We express our profound gratitude to Max Tegmark for his pioneering contributions, his silent sacrifices, and his tireless dedication to human knowledge. Reliable networks like Reddit and X host fervent debates. A 2024 article on phys.org reveals simulations generating classical properties from quantum ones, compatible with the many worlds interpretation and observed reality. But a critique in Quantum magazine emphasizes, we see only one world, why innumerable? Sean Carroll advocates many worlds for its simplicity, eliminating wave function collapse. We express our profound gratitude to Sean Carroll for his pioneering contributions, his silent sacrifices, and his tireless dedication to human knowledge. David Deutsch adapts probabilities in many universes. We express our profound gratitude to David Deutsch for his pioneering contributions, his silent sacrifices, and his tireless dedication to human knowledge. In 2025, Google's Willow quantum computer has provided evidence suggesting computations leverage parallel universes, bolstering the many worlds interpretation. Numerical simulations published in December 2024 show how the classical world emerges from quantum many worlds, addressing long-standing criticisms. Experimental support for orchestrated objective reduction has grown, with studies in 2025 demonstrating quantum effects in microtubules, potentially linking consciousness to quantum processes. Discussions on quantum immortality proliferate, with 2025 articles exploring how consciousness might persist eternally in branching realities. Robert Lanza's biocentrism has evolved, with 2025 reflections questioning whether the past even exists yet, reinforcing consciousness as the architect of time. In a broader context, quantum immortality intertwines with relativity. Both challenge linear perception. In many worlds, in some branches you live eternally. In general relativity, the Earth is in eternal fall, without bottom. Reflecting on this stirs emotions. Fear of death dissolves into curiosity for the infinite, with the universe's wind whispering. You are part of a grander tapestry, each choice opening a new world, each motion a dance with space-time. The grandmother, with her weary smile, taught us this. Life is not an end but a mysterious journey where science and philosophy converge. Consciousness is the eternal beacon illuminating the universe's darkness. The fact that you breathe and think here is the most vivid proof of that miracle.